Hello Geometry. This is lesson 2, segment relationships, part 1. And obviously at the end of this lesson, our learning goal is to be able to identify, define, and justify these terms shown here. So let's get started. So the distance between 2 points is what we call segment length. It's how far is it from point A to point B. That would be its segment length. We find that by just subtracting the coordinates. So again, if we look at here at number 1, PR, since it is on the number line, you could just simply count 1, 2, and so on. But to be more efficient, we can just take -5 minus 4. And the reason why we put it in absolute value is because you can't have a negative distance. Because here, when we work this out, we'll see here. Subtraction means add the opposite, so -5 minus -4 is -9. Well, can you have a negative distance? No, you can't go negative miles. You can only go miles, right? So our answer would be 9. Right? I think we can all count there. QT, again, just take -2 minus 8, because that's what our coordinates are here. Subtraction means add the opposite, so I get the absolute value of -10. The absolute value of -10 is simply just 10. And lastly, you can always just count, and I saved it for this one because it's just a quick little one. QS, from here to here. 1, 2, 3, 4, 5, 6, 7. So you have different ways you can go about a problem like that. Use the number line at the right to answer 4 through 6. So GH is 31, and HI is 10. And we want to know how far it is from G to I. Well, I think we're smart enough here to see that the green and the red segments add up to the whole blue one, so we're simply just going to add those totals, and we get 41. Now this time they're telling us GH is 45, so from here to here is 45, and GI is 67. G to I is 67. And we want to know the red part here, HI. This time we're given the whole in blue, and we know part of it in green. So how do you find the missing piece? Well, you just subtract it. So you have the whole, and you subtract the part you know to get the piece you want, and we find that to be 22. So what we did right there is called the segment addition postulate. It's just knowing that 2 little segments, like AB and BC, add up to the whole big segment from A to C. Okay? So how do you formally write that out is right here. AB, small piece, plus another small piece, BC equals the whole AC. So in these next examples, we want to sketch a picture, write the segment addition postulate, and then find the missing measure, okay? So it says A is between D and B. So here's my segment. Here's D, there's B, and A is somewhere between. And then it wants us to write the segment addition postulate. So I'm going to have DA plus AB equals the whole DB. And now they're telling us some information here. So if DA is 4 and AB is 5, what's the whole DB? Well, we know that 4 plus 5 equals 9. Okay, let's try it again. R is between B and Y. Here's my segment. B, Y, here's R. Now we're in segment addition. Remember, your 2 little pieces equal the whole. BR plus RY equals BY. Now it's saying BR is 5 and BY is 12. So the whole guy right here is 12. Then what is Ry? So remember, we know the whole thing equals 12, and we know a piece of it, so we have to take away what we know to find what's missing. So 12 minus 5 is 7. All right, so number 6, it's giving us some information about our segment over there, and we want to find the value of y. Justify each step, and then find the measures. Okay, so let's label what we know. So we know that GH is 7y plus 3. And then we know that HI is 3y minus 5. And then the total is 9y plus 7. So what's the value of y? And then we have this word justify. Now we're going to do something you haven't done before. We're going to write a little proof. And it's nothing that you haven't done except we have to be formal about it, okay? So when you write a proof, you have to start with what you know. Well, we have a segment. What do we know about the segment? It's broken up into 2 different pieces. So we can start with the segment addition postulate, okay? So let's write that out. GH, a piece plus another piece, HI, equals the whole GI. And now when you justify, you have to explain yourself. So why did we write that? Well, we wrote that because that is the segment addition postulate. And yes, you have to write all these words out. That's just how it is when you are writing a proof, okay? Okay, now what else do we know? Well, they told us what GH, HI, and GI stood for, so let's plug it in. So GH is 7y plus 3. Now just copy down, so plus. Now what's HI equal? 3y minus 5. And GI equals 9y plus 7. So how do we get from the first step to the second step? We just substituted. Substitution property. Okay, now when you're solving for y, what do you always do? You add your like terms, right? So 3y plus 10y is, excuse me, I was ahead of myself, 7y plus 3y is 10y. Now add your constants together, 3 and negative 5 gives me negative 2. Now copy down the rest, 9y plus 7, and we just simplified there. Again, we're just solving for y, so I want to get all my y's to one side. So I'm going to move my 9y over by subtracting. So 10y minus 9y is just y, minus 2 equals 7. And that was subtraction. That's a property. Send my page here. Now our last step is to get y by itself by adding 2 to both sides. So I'm going to get y equals 7 plus 2 is 9. And that is the addition property. Yay, so we finally solved for y. Okay, now let's go back to the question here. So it says find GH, HI, and GI. Hold on, real quickly, I just want to explain. So when you write a proof, each thing should line up with each other. So here's step 1, here's your reason, step 1. Here's step 2, here's your reason, step 2. 3, your reason, 3. 4, 4, and then 5 and 5. So that's how it should always line up. You shouldn't have more steps than reasons. That should all line up. Okay, now back to GH, HI, and GI. So I know that GH equals 7y plus 3. Now I'm going to plug in y for a 9 for y. So 7 times 9 plus 3. And then I get 66 there because 7 times 9 is 63 plus 3 is 66. HI equals, let's see, 3y minus 5. Plug in for y. Then I get 3 times 9 is 27, minus 5 is 22. And then lastly here, GI equals 9y plus 7. Plug in for y. 9 times 9 plus 7. 9 times 9 is 81, plus 7 is 88. And how can you know if that's reasonable? Well, here are my two small pieces of the segment. And if I take 66 plus 22, do I get 88? Sure do, so it checks out. We'll do more examples of these justifying problems, so I know they're kind of funny at first, but we'll get better at them, okay? So don't get discouraged right now. Okay, so find the length of each segment. I'm just going to count because it's giving me a number line, and that's the easiest thing to do right here. So CE, 1, 2, 3, 4, 5, 6, 7, 8. So CE equals 8. Now, when you write, when you write what a segment equals, you don't put the bar on top. When you're talking about its length, you just have it as CE with no bar on top. Okay. And then FD, 1, 2, 3, 4, 5, 6, 7, 8, 9. FD equals 9. I promise there's a reason why we're doing this again. Okay, now let's do this next one here. CD, 1, 2, 3. CD equals 3. And FG, 1, 2, 3 is also 3. So when we have two segments that have the same measure, we say that they are congruent. And our congruent symbol is a little squiggle and then an equal sign. That is our congruent symbol. So when we have congruent segments, this is how you would write the congruent statement. CD is congruent to FG. But if I wanted to talk about their measure, I'd say the measure of CD equals the measure of FG. Okay, so remember we're talking about the congruence of the segments, you put the bar on top. If you're talking about if they have equal measure, you just have it CD without this bar on top. It's kind of a technicality that we have in math, okay? Use the figure below, find KL. There's that word again. Justify each step. Okay, so let's figure out what we know. They're telling us KL and LM. And then if we look at our diagram here, these little tick marks signify that those two segments are congruent. So KL is congruent to LM. And that's because of these little tick marks that I drew in blue were given to us. There we go. So again, when we have a proof, we have to start with what we know. Well, we know that KL is congruent to LM. And we say that is given to us by the diagram. So our reason is given. Okay, now this next part is just that technicality I was talking about. Since we know that the segments are congruent, I know that their measures are equal to each other. So KL equals LM. And that is by the definition of congruent segments. Okay, so now we know KL equals LM, and we also know what KL and LM equal. So again, we're just going to substitute in what we know. 3x plus 2 equals 5x minus 10. And that was just substitution property. Now we just have a normal algebraic problem. So I want to get all my x's to one side and my constants to the other. So I'm going to bring over my 5x by subtracting. So 3x minus 5x is negative 2x plus 2 equals negative 10. Subtraction property of equality. Okay, again, I want the x by itself, so I'm going to subtract 2 over negative 2x. Negative 10 minus 2 is negative 12. And I'm just going to do this because it's the same property, but you should write it out. And then lastly, we're going to divide by negative 2. So negative 12 divided by negative 2 is 6. And that was division property. Okay, now let's go back up to make sure we answer the question. Find KL, so now we know what X is, and we're going to plug in to find KL. So I gotta extend my page here. KL equals 3x plus 2. Plug in 6 for x. 3 times 6 is 18, plus 2 is 20. Perfect. Now again, you can check to see if your answer is correct. If you scroll up, we know that these two segments here are congruent. And if I know this guy's 20, ln should also be 20. So I'm going to sneak that in right here. 5, or we found x to be 3 minus 10, or was x? Nope, it was 6. 5 times 6 minus 10. So I get 30 minus 10, and we get 20. So therefore, we check out again, our math was good. Okay, now a midpoint of a segment is just the place on a segment that divides the segment into two congruent places, or pieces, excuse me. So the midpoint of our segment here, AB, is M, because it divides AB into two congruent pieces. And again, we know that because it's marked by these tick marks. Now, a segment bisector, think of it as like a knife. You're cutting something. It's something that cuts something into two equal pieces. So, in our example here, we have a line L is bisecting our segment KJ. And again, remember, we know that because it's telling us by these little tick marks that from K, from here to here is equal from here to here. And that is a segment bisector. Something that cuts the segment into two congruent pieces. So now we have a couple formulas we can learn. The midpoint formula of a segment is you add up your two coordinates and divide by 2. So it's just the average of your midpoint. Of your coordinates. So you take your two coordinates and again divide by 2. So that's for like a one-dimensional segment. And if you have something on the coordinate plane or it's two-dimensional, you just have to do it twice. So on our example here, you take your x coordinates, x1 plus x2, divide by 2, and then comma, you do it again. Add your y coordinates together, divide by 2. So it's the same idea as this, you just do it twice, times 2. So FG has endpoints at -3 and 7. What is the coordinate of its midpoint? Remember, you're just finding the average. How do you find the average of something? You add up its coordinates, divide by 2. -3 plus 7 gives me 4. Divide by 2 gives me 2. Let's just check it out. So there's my midpoint. It's the same distance away. 1, 2, 3. 1, 2, 3. We're good to go. Find the coordinates of the midpoint AB. So now since we're working with coordinates, you just do it twice. So first start with your x's. -3 plus 5. Divide by 2. Now do it with your y's. 2 plus 10. So 2 plus 10, then divide by 2. Playing musical markers here. Okay, so now let's just crunch these numbers. -3 plus 5 is 2 over 2 gives me 1. 2 plus 10 is 12. Divided by 2 is 6. So my answer here is 1, 6. We're gonna skip this one, I don't think we need to do it. It says M is the midpoint of AB, find the coordinates of B. So this one's a little different here. This time, they're giving us one endpoint and the midpoint, and we need to find the other endpoint. So I'm just gonna kind of draw a little picture here. So here's where I'm starting. I need to find my endpoint. It won't work. And I know my midpoint. So let's label 4, 3. Here's my middle. I know that's -2, 1. And I'm looking for this guy here. Okay, remember that this distance from here to here needs to be the same from here to here. So let's just think about this logically, okay? So how am I going to get from -2 to 4? So what's the difference between 4 and -2? Here's -2, here's 4. How many spots are between here? Well, just take 4 minus -2, and we get 6. So I had to do +6. How do I go from 1 to 3? Well, you all know that, that's just by adding 2. So now I just do the opposite. So this time I'm going to take -6 to get from here to here. So -2 minus -6, and I get -8. Now 1 minus 2 is going to give me -1. So my answer, -8, -1. And for time, we're going to skip that guy too. All right, we finally made it to the last problem. It says S is the midpoint of RT. What are RS, ST, and RT? Justify each step. So I hope we're getting a little bit more comfortable with these. Again, we're writing a proof, but just start with what we know. So what do we know? Well, it's telling us S is the midpoint of RT. Okay? So I know then that from R to S is congruent to S to T because that's the definition of a midpoint. So let's start there. So we know that RS is equal to the measure of ST. And that is the definition of a midpoint. Okay, well, do we know what RS and ST are? No, but we know what they equal. So let's substitute in what we know. 7x minus 3 equals 3x plus 1. And all we did there was substitute, so substitution property. Okay, now it's just an algebra problem, so don't get bent out of shape. Bring your x's to the same side, so I'm going to subtract 3x over 7x minus 3x is 4x. Subtraction property of equality. Now add your 3 over to get rid of it, so 4x equals 4. Addition property. Now lastly, you just divide. 4 divided by 4, x equals 1. Okay, now let's go back to the question. Did we answer what it wants? What are RS, STE, and RT? So now we got to plug in here. So we know that RS equals 7x minus 3. Plug in 1 for x. 7 times 1 minus 3, 4. ST, 3x plus 1. Plug in 1 for x. 3 times 1 is 3, plus 1 is 4. And lastly here, we know that RT, we just add those two together. 4 plus 4 is 8. Awesome. Thank you guys. I know this got kind of long. Ask me questions, and I bet you we're still kind of having some gray area of things that are new to us, okay? So let me know if I can help you out.